I think a lot has been said during the day about the refrigerant, especially at the panel discussion. And a lot of things could be repetitive, but I will try to make it much more interesting than technical. Just a disclaimer that I'm not a technical person. This was supposed to be done by my technical leader, but I'm doing it on his behalf. He had other engagements. So we talked about the choice of refrigerants, right? So of course, there are many drivers that make it happen, right? There are regulations, Montreal Protocol, the Kigali Amendment, and then we talked about safety, energy efficiency, that a lot of people covered in the sessions after me, that how much energy efficiency is getting important, the reliability, especially in high ambient conditions at ours. But at the end, it's all about the total cost of ownership, right? As a business person, I always believe that, okay, complying to regulations is important. Being socially responsible, making to environment is extremely important. But at the end, these changes, these transitions, these choices are driven by the economics. The economics of how costly it is, how efficient it is, the total cost of ownership. I mean, just to give you an example, and it was briefly touched upon about the automobile industry this morning. When Europe rolled out their first F-gas regulation, it was about the MAC directive of mobile air conditioning, replacing HFCs in the automobile industry, which was 134A, a very high GWP refrigerant. And that was back in 2013. And the regulation was that the automobile industry in Europe had to choose a refrigerant with a GWP of less than 150. And they had this option of going to a fluorocarbon. So Honeywell, with their peers in the industry, Chemours, they put a joint development program, and we built our first HFO molecule, 1234YF, for that industry. And the other alternative, an option for the industry, was to choose CO2. And CO2 has been there. By the way, I have my own reservations calling CO2 or ammonia as natural refrigerants. They are as synthetically produced in an industrial plant as fluorocarbon refrigerants. So back to our automobile industry, they did all their tests, and at the end, long story short, what happened was to be able to adopt CO2, because it's high pressure, they had to put in a lot of more metal in the car, which was adding a lot of cost and adding to the mileage. Approximately a mid-sized car, the added cost was like around $400, which is big time cost increase for automobile or a car. And they chose for HFO finally because it was overall a fraction of the cost to do that. And that's how the automobile industry then finally transitioned to HFO 12345F, and now we have like more than 100 million cars on the road and keep coming out, right, globally with that refrigerant. So just one example how, an alternative chosen in the industry, again, driven by economics, right? And in our region, other than having a GWP, which will be complying the Kigali Amendment, the energy efficiency, which again impacts the savings. Water is very critical, as I said, so water savings would be very critical for the industry to choose. The circularity, the recyclability of it, and overall the operation excellence, right? So these are some of the drivers that would help it. This chart you might have seen many times. We have borrowed it, for example, from Train. And this just lays out the different regulations. EU F-gas was the first to push out the GWP-based and the quota-based story, and they keep cutting the quotas down, and that's why HFCs are being phased out. And then you see at the last is our region, which is basically the Article 5 Group 2 country, and have a long way out to phase out HFC. This chart is basically saying if you're putting a high-capacity chiller, a low-pressure chiller like a district cooling plant, you're looking at a 20, 25 years lifeline. And that completely exceeds the timeline of the Kigali Amendment. So the decisions which are being made today for buying a new chiller should consider not only a Kigali Amendment, much beyond the impacts. And that's not an easy thing to estimate, but at least they should not be going or choosing HFC as a refrigerant, because then you're going beyond, as the lifeline of the chiller, you're going beyond regulations where you may have to phase the availability of the HFCs, because it's not about importing here, but also where the HFCs are produced. most of them in China, for example, and I mentioned about the pricing dynamics, how it is for HFC recently. So these are the factors that are going to impact, and should be taken into consideration. Few examples for alternatives which are being adopted. For example, 410A, which is a high GWP refrigerant, very effective and efficient refrigerant, but has a replacement called 454B, which is significantly lower GWP, again, a much higher energy efficiency, especially in high ambient conditions. And now we have all the compressors and the related parts available for it. The speed to conversion is happening much faster as what we are seeing. Also in our region, the growth, the transition for this refrigerant is pretty fast related to these factors. One chart which we have borrowed from a Eurovent data, which kind of maps the energy efficiency performance of 454B, 32, and 290. And you can see that the 454B or 32 or fluorocarbons are relatively higher energy efficient. And this is the database coming from Eurovent, Europe. Similarly, 134A, so first to phase out in automobile, and now we see the commercial air conditioning space slowly moving to ZE. I think Europe, we have 1,000 chillers almost running on ZE or more and growing. And the 515B, which is the non-flammable A3 alternative to ZE. Same story, much lower GWP, much lower on energy efficiency, much better performance in high ambient conditions. The compressor envelope, as you see, is much broader. So the energy efficiency, especially higher ambient conditions, is much better. And again, that relates to the water consumption also. Because of a lower temperature discharge, you consume less water. Again, similar data for HFCs and HFOs in this space, 1234ZE, coming from Eurovent again, mapped again 290. Of course, 290 becomes, because of high flammability, has a limitation on charge, and that's why it has a limited scope in terms of capacity, and you see ZE much more efficient, especially at higher ambient conditions, and we see that performance happening here. Another example on industrial, and this is something where we are seeing a lot of disruption also happening, especially, I don't know if Murad is still here from Danfoss, but from friends at Danfoss, for example, they lead the turbo technology, the oil-free, the emergence of oil-free compressor. And this is disrupting because this completely goes hand in hand with HFOs and delivers a very high energy efficiency, especially on high ambient conditions. Not go into the details or data, but just for the interest of time, but just to let you know, versus ammonia, you're seeing almost 35 to 40% more efficiency with this oil-free compressor. We have partnered with a chiller manufacturer in Europe, done the test on site with Danfoss, and we can share this data. Similarly, in high ambient conditions in Abu Dhabi, the chiller, you can see the compressor envelope, which is much broader at higher ambient conditions. And you see the COP comparisons versus 134A and ZE. Again, energy efficiency and total cost of ownership is key criteria. So overall, just to summarize our discussion, yes, we need to go for a lower GWP. We need to comply with the local regulation as Kigali kicks in, and there's multiple refrigerants now for different applications, where 454B, 513, and a friend from Aramco this morning mentioned about them, ZE for medium pressure, higher energy efficiency. The energy subsidies go away. The regulators, as well, the facility managers are extremely sensitive about this now. This is one easier way to save money, whether you are running a supermarket or a building. I think this is one area where we see as a main driver in terms of choice of refrigerant or technology or a chiller type when decisions are being made on the drawing board. Water savings. This is one driver which is so important for our region because getting water will be getting more expensive. It's getting the attention of the regulators. And again, an important point for choice of refrigerant and equipment type. and when you're choosing to whether cool or refrigerate your facility. Circularity, this will grow as the refrigerant prices go up. You will see more and more recycled solutions to be offered, where you're able to recuperate, take your refrigerant out, recycle it, and load your systems back to keep it more economical and manageable on cost. And overall, operation excellence is critical, something which is least cost to operate, easy to handle. You have the right skills to manage it. It's lower pressure, so lower amount of leaks, and that will determine the choice of refrigerant going forward. That's the summary of my thoughts. Thank you very much.